Okie dokie, today we're doing an implicit differentiation problem. So here we're trying to find the derivative of this function, but it's kind of difficult because it has y's in it. So to solve this, what I'm going to start doing is just finding the derivative of things I know how to find the derivative of. So I'm going to make a 6x squared from this first term, so I'm going to cross that out. And then it's going to be plus, I'm going to just say plus the derivative, ddx, of this 4x squared y cubed thing. And then the minus 6y is going to turn into minus 12y. And then if we remember, when we take the derivative of something, if it's u to the n, that the derivative of u to the n is n u to the n minus 1 times u prime. So because we don't know what u prime is, or because we don't know what y prime is here in this instance, we just get a right y prime. And then 42 is a constant over here, so 42, or excuse me, 0. It doesn't change. So I'm going to cross those two out. Now I need the derivative of this 4x squared, this 4x squared y cubed mess. So the way I'm going to do that is pretty simple. I'm just going to, did I do the, let's see, I'm looking at my notes here. I did do the product rule, it looks like. So I'm going to do the product rule. So we're going to take u, and I'm going to take v here in the product rule. So u prime is going to be 8x, and then v prime is going to be 3y squared times y prime. Okay, and then for the product rule, remember it's u prime v plus u v prime. And so to do that, u prime is 8x. That's going to be times v, which is y cubed. That's coming from up here. Then plus u, which is 4x squared, times v prime, which is 3y squared. Oh, my pen is running out of ink. 3y squared times y prime. So I'm going to put all those things into this one equation. So I have 6x squared plus 8xy cubed plus 12x squared y squared times y prime, then minus 12y times y prime equals 0. Then what I'm going to do is I'm going to move everything that doesn't have a y prime over while also factoring out a y prime. So first I'm going to factor out y prime, and so I'm going to get 12x squared y squared minus 12y. Because both of these terms have the y prime in them, I'm pulling the y prime out and just leaving this in there. And then I'm also going to subtract these two terms over to the other side. So that's going to equal negative 6x squared minus 8xy cubed. So these terms just move to this side of the equation. So 2 steps in one. And then to get y prime, I'm just going to have y prime over here, and we divide out the other stuff. So negative 6x squared minus 8xy cubed over this 12x squared y squared minus 12y. And that is going to be my y prime. And so that is how you do implicit differentiation. If you don't know the derivative, just say, hey, I'm going to take a pause here. I know the derivative of this and this, but I'm going to take a pause here. We solved this part over here. Once we figured it out, we plugged it in, and then we just simplified until we got y prime all by itself, which is going to be, our f prime of x, and also our m, and anything like that as well. And so that's how you do the derivative when you have a y in there. Hope that was helpful.